Hello everyone, how are you all? I hope you all are doing very good and you all are also enjoying the learning from our playlist of previous year question series of each chapter in CBSE Class 10 Physics. Now I brought you one more video. In this video what we are going to do, we are going to take three resistances. See, first resistance 1 and resistance 2 and resistance 3, and I have to say that we all are doing here this as a part of experimental learning. A playlist is created in my YouTube channel which is named as experimental learning, in which I am teaching children how to practice experimental learning. I have explained all equipments present in CBSE Class 10 Electricity chapter, and I am making them practice and how to do it on their own also. Okay, so now here in the last video what we studied about this project board, or we also call it as the breadboard. We also said that these five will be connected in series. These five will be connected in series means they all will be connected as a single point. So I also said that if we connect three resistances in series, the total resistance should be 3R. And if we connect three resistances of equal value in parallel, the total resistance should be reduced to 3 times, correct? That is what we are going to verify now. Okay, so now let us first find out the resistance of this value of this resistance. I'll keep this resistance, I don't know the value of the resistance. First I'll keep it 200 ohms. It is not showing anything. Increase the range to 20k. Not showing anything. Increase the range to 200k. Yes, resistance of this resistance is around 160 kilo ohms. 160 kilo ohms. Okay, so now what I am going to do, see, theoretical also I'll explain first, then we will go to practical. Okay, so now I have a resistance value of 160 kilo ohms, correct? So now what am I going to do? One resistance is there, and I'll connect this in series and one more in series. It is 160 kilo ohm. It is also 160 kilo ohm, and this is also 160 kilo ohm. If I connect all these in series, the equivalent resistance will be how much? 160, 160, 160. It should be 480 kilo ohm. In the same way, if I connect these three resistances in parallel, 160, 160, 160 kilo ohm, kilo ohm, kilo ohm, kilo ohm. What should be the equivalent resistance now? 160 kilo ohm divided by 3. Approximately 3 5 is 15, 53.3 kilo ohm. Correct? So because when equal resistances are connected in parallel, the equivalent resistance will be R by 3, because 3 resistance we connected. If 3 equal resistors are connected in series, the equivalent resistance will be 3R, because they are connected in series. So 3R becomes 480 kilo ohms, R by 3 becomes 53.3 kilo ohms. Now let us verify that practically. Okay, now let us take those three resistances of 150 kilo ohm. See, 1, 2 and 3. Okay, now first I am going to connect them in series. On this breadboard I am going to connect them in series. If you don't know how to use this breadboard, please go to our playlist of experimental learning and watch the video on breadboard. Why am I connecting like this? How am I connecting like this? If you want to know, and if you don't know that, even though you are watching this video, you will not understand anything. So kindly go and watch and learn and then come to this video, then you will understand. Right. See, now I connected 3 resistances in series. So now let us verify the equivalent resistance of this. What should be the value? 480 kilo ohm. I will keep here. First I will verify resistance from here to here. Around 177. It is showing 180. Okay. Now from here to here, what is the resistance? Let us see. I changed the range. Now see here, 533. What do we get? We have to get 480 kilo ohm. We are getting how much? I will keep here. I will connect to here. That is better. See, we are getting resistance of 567 around, correct? 530 kilo ohm. 480 was the answer we should get. We got 530 kilo ohm. Generally what happens, children, the practical things, when we go into practical things, exactly point to point value we will not get. We will get some variation only. So what we got now, that is acceptable only. So now let us connect them in parallel now. If we connect them in parallel, we have to get resistance value should be around 53 kilo ohm. Correct? So now let us connect them in parallel. I am trying to connect them in parallel now. The resistances values will be varying, will not be fixed. Means that's why we gave tolerance value for these resistances. So I connect all these them in parallel. Let us verify now. It should be 53 kilo ohm. So I will keep it at 200 kilo ohm. See, 58.9 kilo ohm. Are you able to see it? See, 59 kilo ohm. We have to get 53.3. We got 59 kilo ohm. I am not sure if you have seen the series connection resistance. I'll reconnect the series connection once and I will show you. Okay, I have connected them in series now. Now I will show you the series value resistances. How much we have to get? Around 480. $2,000 I will keep. See, 532 kilo ohms, right? This is how we can verify that when resistances are connected in series, the resistance will increase. When they are connected in parallel, the total resistance will decrease. Thank you so much, children. We'll meet in the next video. We are doing so many videos on experimental learning. Learn and try to habituate that practical thinking. Okay? Thank you so much. We'll meet in the next video.